here, and I'm not sure. You can see there's only one green left on this beauty, so that's what I'm operating it on. The battery in the boat is a 12-volt battery, and it'll last for days. But this one, the transmitter, I'm not sure how long and how safe it is to have it out. Once it's surfaced, it'll be okay on the water because it won't go down. It'll just stop somewhere, potentially. Another little air bubble problem in it. We'll have to make sure that the owner will know that, but it's working fine. It just does get a little bubble of air somewhere. I'm not sure where it is. As you can see along the back of it, there's a lot of vent holes. There's vent holes here, and then there are vent holes back here, so I'm not sure where that is. Maybe it's just up along the middle. Maybe it needs a little hole in there that collects a little air. I'm going to bring it back up. A quick blast pops right up, so it responds very nicely to its commands. Go down again. I don't know if I should bother to figure out where that air is getting trapped, but it seems like it's probably up along the back of it. So I'll just let him know that when it dives, it just has a potential for getting air caught in it, and just to run it forward, it'll probably come out those back holes in it. This is a Russian Alfa Class Submarine. They were built in the 50s. They're out of service now, 100-killer submarines. Titanium hull, nuclear reactors, one of the fastest submarines at the time. They could actually outrun torpedoes, was one of their characteristics. And as we heard earlier by Mr. Hollins, they actually were quite noisy, and they did have a lot of problems with the titanium welds, which was one of the reasons that they took them out of service. Although there are still some Russian submarines with titanium hulls. So at this point I am happy with how it's trimmed out and happy with its operation, and happy to announce that the build is pretty much done. I just have to prepare and finish up. Actually, I've started the manual, operation manual, and ship it to Japan. So there it is, 2006, October 29th, California, Los Angeles, California. This is Mike Wernicke, President and CEO of International Ocean Research, signing off. And 31st, Halloween evening. This is the day following the previous discussion and the observations of the ship in the floating tank. I'm going to do a normal opening of the hull procedure as it should be performed, in the sequence it should be performed after, let's say, it's come out of the lake, or you've just decided to open it to check the batteries, charge the batteries, or recharge the ballast tank, pressure tank. So this is the normal procedure. First, to remove the rear antenna from the hull. Inserting the T-handle into the small port in the side. Pressing it enough just to open it a slight bit. Going to the other side, inserting in the small opening on this side. And we have fairly easy liftoff. It's precisely, generally exactly the sequence you would follow. To close it up, place it back in position. Depress the pressure cap, snaps down. Go to the other side and I will lock this one down. If you can't see it, there's a little yellow clip in there. That's what holds it down with the pressure tank, and that is it. Generally it takes a little touch on this particular one to do that, and that is the sequence. One more time. Opening the hull. This perfect spot to lift it is actually a balance point. Shake it a little bit, loosens up the pins which are aligning it to the lower hull. And it lifts off. Stuck a little bit today, but that's it. Well, now I'll take the camera off its position and view some of the internals of it. This is the final sequence. I've aligned everything. I've added some ballast foam, some of it of which is that foam you see right there ahead of the battery. Helped to do the final flotation of it, which I was doing yesterday. Couldn't see, it was inside. But I did add two small pieces of foam. This is one of them. One complete piece here, and then there's one here. And there's one here. This gave me my side-to-side balance. And I added some in the stern, and I added some in the inside of the upper hull, which I'll show you. What you see there in the back of the upper hull, held in by that bracket. I haven't glued it in place. I can put some RTV on it momentarily. So that little bit there, plus the other pieces, are what gave it its final trim yesterday and gave us that beautiful run in the tank. So now I will take it off and we'll have a view at some of the closer of the internals. This is the forward view showing the foam in the battery. Again, these are additional pieces I added. This little piece here, small piece of foam there. Believe it or not, a quarter of an inch off of this one gave me a level balance. It's all it took, really. It's so sensitive. I didn't realize it was that sensitive to the foam in it and the weight in it. And that piece in the stern there has also been added, and that was also one of the final and last pieces of foam I put in, other than that, the other one I showed you in the top of the hull. And the clips here are of my design. These are what hold the top and the bottom on. When I was pushing in with the T-handle, what was happening is that I've got a 30 thousandths, you see I have a socket head cap screw in there, which catches the tip of the T-handle and keeps it from slipping up on it, pushes it in, 30 thousandths stainless steel feeler gauge over the top, holds in the WTC 3.5 and gives the action I need to hold the top hull down when these compress that way. Of course, it holds this little rib, which is also on the top hull, holds the top hull to the bottom hull. Both sides are the same. Small hole in this side and on the other side, if I can find it here, pushes this in and does the same thing. So it's a 30 thousandths feeler gauge, stainless steel feeler gauge, which holds that in place. These come out, and out comes the hull, the WTC 3.5. So what I'm going to do tonight is my final assembly before I send this to Japan, is I'm going to reconnect the two clevises. I've tapped these for a 440 socket head cap screw, stainless steel socket head cap screw. They interlock like that, and screw will go in the top there and in there. So I'll begin doing that, and that'll be the final mounting for the operation of the stern planes. One for the dive and surface, which really is essential because it operates with the automatic pitch control, which is visible right there. It's APC, I think now he calls it the 3. We're not getting any glare on it there. That's it right under there. I don't know if we're seeing it, getting a lot of glare there. That's it. That's the APC pitch control, which keeps it on a level plane when it's below the surface, just doing a run. And the other side, of course, is the other side here is the rudder the other direction. So you can see the foam. I've got two clips here which hold the back foam down. I removed a weight I had in here. And I added my propeller shaft and the flexible coupling. As I explained yesterday, I didn't originally trim it with that, so I had to take out the weight which I had in there. So that is the final configuration of it as it stands. Battery, forward position. I added this foam, and also other than ballasting, it kept the battery from sliding forward. I was having a little trouble with it. I noticed when I lifted it up, it moves a little bit. At this point, that doesn't affect it. But I was going to head further, and this keeps it from doing that. So that's pretty much it. This is the extension I put onto the positive and negative connection to the battery. Everything runs off of this. One connection goes into the speed control. Speed control has a battery eliminator circuit built into it, which is down here, and that feeds then, I think it's 4 point whatever volts need to go to the fail-safe, to the end motor, the receiver which is underneath, etc., etc. And this is the extension I built onto the Merriman's WTC 3.5. This gives me 20 surfacings. It's modified from his, which only came to the top here, so I've got twice of the capacity his does. With a large battery, this probably can run for 2 hours. I haven't really tested it for the maximum amount of run time, but I suspect there's almost an hour to hour and a half with the Airtronics 4-channel radio that it could still operate on the surface. I don't know if it would blow and still come up, but it looks like about an hour, hour and a half.